The NanoAvionics EPSS is a compact green monopropellant propulsion system designed for small satellites. With a relatively high thrust in a small system, it suits the requirements of a large set of satellite missions.
The idea of the EPSS is to provide nanosatellites with features like a longer mission duration thanks to orbit keeping, much more maneuverability, which is relevant for constellations, and of course a deorbiting capability.
NanoAvionics EPSS is a blow-down-tight green monopropellant propulsion subsystem with a beginning-of-life thrust of 1 Newton. Our standard propulsion configurations come in sizes from 1.5 to 3 units. This allows to offer a total impulse in the range from 1 to 4.5 kN/s with a wet mass ranging from 2 to 4.5 kilograms.
The highly modular NanoAvionics propulsion system design approach allows its total impulse and delta-V capabilities to be configured to specific mission needs by changing the size of its propellant tank. The standard single thruster configuration can also be adapted to have multiple thrusters for increased thrust. As an extremely versatile system, well suited for orbital maneuvering and maintenance of nano and micro satellites, it also offers required thrust levels and fast response times for the reaction control systems of larger spacecraft.
Well, the history behind this propulsion system is quite long, in fact, if you compare it to the history of nanosatellites. Because it started in 2009, and there was a group of scientists and engineers in Vilnius which started to develop thrusters which worked with ADN, so with LMP103S. And it all culminated in this experiment which has been put into orbit in 2017, which was the EPSS 2 satellite. And it was really a success because with a very compact system, they managed for the first time to have a nanosatellite which was maneuverable in orbit. Then even more investment was done by NanoAvionics in order to develop really a standard propulsion system which could make a commercial off-the-shelf component out of it. And this of course took some time, a lot of effort, a big team which was growing more and more. But in the end it was very successful because very quickly we had the first M6P platform in orbit with first demonstrations, and the team has never stopped improving the technology, and now the system is able to make very long hot firing tests on ground and in orbit.
In the recent weeks, NanoAvionics propulsion system went through an extensive qualification campaign to determine system performance. The overall qualification campaign involved a variety of environmental tests such as random vibration, mechanical shock, and thermal vacuum cycling to determine the lifetime of our propulsion subsystem. Hot firing tests were performed to determine thrust levels, propellant throughput capabilities, and also thermal characteristics of our system. The longest firing pulse of over 15 minutes was reached, which was only limited actually by the limited supply of the propellant that was available. Overall, throughout the whole hot firing test campaign, the cumulative time of firing was over 44 minutes.
The EPSS geometrical interfaces are designed in line with the typical structures of nanosatellites, making it very versatile by enabling easy integration as a COTS component. It comes with a dedicated engine control unit that centralizes all relevant hardware and software functions outside the OBC. And unlike other monopropellant systems which are highly toxic for the operators, the EPSS can be fueled without the need for heavy protective measures, allowing for much safer operation. These three features make the EPSS a real plug-and-play component for the small satellite industry, and the recent qualification campaign success builds upon earlier flight heritage to bring new opportunities for propulsion applications in future missions.
We are very excited and looking forward to the upcoming missions and providing more opportunities to the new space applications.